Okay, lesson 6, the cosine rule. So before we solve problems, we're going to look at when would you use the cosine rule and how do we get the cosine rule, okay? So there's a lake, and you and your friend want to figure out how far it is across the lake from, say, here to here if you're going to canoe. Let's say it's Doha, right? And over here's one side of the Corniche, and over here's the Islamic Art Center. Yeah, you should go down there with your class and figure out how far it is across there, straight line distance, using the cosine rule. Well, if you stood back here somewhere, it doesn't matter, somewhere on the Corniche, you stood here, and you had a compass, so that you could shoot this line here. You could eye along your compass, and then eye the other one here, and well, imagine that's not in the way, so you could walk the straight line distance. So you could figure out this distance. You can find this distance, x and y, and you can find this angle in here using your compass. Boom. So the cosine, and so then you can find this. You can find their length across here, the distance here. As long as you can measure this and measure this. You don't have to measure this. You can figure it out with and you can measure this angle. Then you don't have to measure this distance. You can figure it out with law of cosines. Okay, so law of cosines is useful when you can figure out two lengths of a triangle and you have the missing angle. But I'm sorry. You can figure out two lengths and you're given two lengths and you know the angle between them. Right? Law of sines was when if I knew the side and an angle opposite. Here, I know an angle, but not that side opposite. I know two sides and the angle between them. You can also use the law of cosines when you know all three sides, but none of the angles. So if I did know d, x, and y, but I knew none of the angles, I could find that first angle using law of cosines and then find the rest of them with law of sines. Okay, so let's go ahead. Where does it come from? Let's just draw out oh boy, that's not straight. Okay, it doesn't have to be accurate or anything. Let's go with triangle ABC. Drop that height down again so we have our right triangles. And this is going to be side A over here. And side A, we're going to break it down into something we don't know. This length X here. And then this is going to be, A is the whole length, right? And so if part of that length is X, then this other part is A minus X. Okay, so and we'll call this H here, the height of the triangle, right? The height of the triangle is always perpendicular to the base. Okay, so we got the base down here, we got the height, got our two right triangles. They're both right triangles, of course, right? Okay, so let's write down this time to figure out where does the law of cosines come from. I'm saying law of cosines. That's the way I was raised up. It's called the law of cosines. The cosine rule, same thing. So let's do the Pythagoras theorem 2 times. So let's do Pythagoras theorem for over here. We're going to do leg squared plus leg squared equals hypotenuse squared. And this side is little c. This side is opposite of angle B, so it's little b. Okay, so this side I would have h squared plus x squared equals c squared. And then for this triangle, I will have h squared plus a minus x squared equals b squared. Okay, so we see that in these two equations, we have one variable in common. So let's set both of them equal to h, and then we can set them equal to one another. Okay, we use this trick all the time, huh? H squared equals c squared minus x squared. H squared equals b squared minus a minus x squared. Okay, So if h squared equals this, and h squared equals this, then this equals this. If a equals b, and a equals c, then b equals c. Whichever algebra thing that is, I can't remember the name of it right now. All right, associative or commutative or whatever. Okay, so c minus x squared equals b squared minus a minus x squared. So let's expand this side. So now we're just fiddling around with, oops, I'm sorry, this is c squared. Let's expand this side. And mine is going to come out with the letters different than the way they did it. But anyways, you can look at the way they did it. I think they do I think I messed up by putting didn't mess up, but you'll see it comes out correctly. Okay, so at c squared, I'm going to put the equals b squared minus a squared minus 2ax plus x squared. X squared. I got rid of my squared there, right? So all I did was expand this, right? Binomial expansion, right? A squared minus xa or minus ax minus 2ax minus x times minus x is plus x squared. I bet you're pretty darn good at algebra because it just takes memorization and organization. Okay, so, and now I'm moving this minus x squared over here, so then I got plus x squared. So then I'll have c squared equals b squared minus a squared minus times minus plus 2ax minus times plus minus x squared plus x squared. Yay, we get to get rid of those, right? Minus x squared plus x squared. So now I will have, and let's look at this guy here first, this x. So we're going to take a little break here, and what is this x? Let's change the form of this x. So x, and let's relate it to angle B and side C. So this is the law of cosines, right? The cosine of B, angle B, equals adjacent over hypotenuse, equals x over C. So x equals C, the length of side, oops, I'm pointing up there, C cosine of B. Okay, so we'll substitute that in for x. So then we'll have c squared equals b squared minus a squared plus 2a times side C times the cosine of angle B. And what if it looks messed up here. Let's see here. Let me rearrange things and get it correct. I am looking at cosine of B, and it's the law of cosine, so B is who needs to be over. If I just move, what I'm going to do now is move these guys over to the other side of the equal sign. So I will wind up with, we'll leave them over here, b squared equals c squared plus a squared minus 2ac cosine of b. Let me rewrite that. So there, do that little thing your book does. B squared equals c squared plus a squared minus 2ac cosine of b. And so it doesn't look quite right because I put the a minus x over here instead of over here. So if I had switched the x and the a minus x, then I'd taken the cosine of c. So I wound up, it's correct, but it's better when it looks like, so you could, it works for every side. I just chose my letters kind of backwards. So you would wind up with, if I change this to a C, and this to B, and this to B, right? Because it works for any sides and angles. I wind up with, if I'm talking about angle C, it would wind up being C squared equals A squared plus B squared minus 2AB cosine of C. Cosine of angle C. So it's not that hard to memorize. You probably already have this memorized, probably stuck in your head, because it's the Pythagoras theorem minus 2AB, you got your A and your B, 2AB cosine of C. Anywho, there's the proof of it, and it's in your book. Too long a video. We'll do some solving in the next video. Solve some of the activities.